Shortest distance, question 2. Given the graph of a function f of x, determine the shortest distance of the point P from the function graphically. Show your work and explain the steps. Now this is a very interesting question and I thought it to take right in the beginning. Well, how do you find shortest distance from a point which is outside the graph? Of course, outside. If it is on the graph, then the shortest distance is 0, okay, to the graph itself. Now, the steps are, you should draw a normal from the point to the graph. So this is your point P, 5, 1. To find the shortest distance, what we need to do is to draw a normal. Normal means perpendicular from P to the graph. If it was a line, it was very easy for me to draw perpendicular. How? The slope of the perpendicular is negative reciprocal, correct? So I can find the slope of the line and then do negative reciprocal to use the slope from the point and get my answer. Here, because it's a curved surface, I don't know the slope at the point where I'll have normal from point P, so it's kind of tricky. So what we will do here is, we'll try to draw a tangent to the line, correct? So, and we can kind of assume, it seems that this seems to be some value here. So what we will do is, we'll try to draw a tangent to the graph, right? At some point where we think it could be approximately, right? So it seems to be here somewhere, correct? So what we do is we draw a tangent to the graph and we will draw from the tangent negative reciprocal normal to the tangent, right? So we see in this graph we can draw this kind of a tangent here, right? So that seems to be a good approximation, and let me draw a tangent here. Okay, so I'll draw a tangent here to the graph like this, right? So my tangent is going like this and it's just cutting it here. So now what we will do is, you know, the slope of the tangent is what? Slope of the tangent is rise of 1, 2, 3 and run of 1, right? So slope of the tangent is 3 and 1 is positive 3, correct? Slope of tangent is 3. So from this point, if we take minus 1 over 3, so the slope at this point will be, so for perpendicular, the tangent slope should be equal to minus 1 over 3, right? So what we will do is, minus 1 over 3 is going down one step, that is minus 1, and 3 is 1, 2, and 3, and we reach our point. That means this point is perfect for our point. So it's kind of a hit and trial thing. So we can join them. And well, we say this is the normal from our point to the given curve, right? So we can extend it, doesn't matter. So that becomes a perpendicular from our point to the curve. So we just estimated and did it, okay? So it's a hit and trial method. So now once we have this perpendicular with us, then what we can do is draw a right angle triangle, correct? And then figure out the length of or the distance between the point and the curve, the shortest distance. Okay, so what we'll do is we'll make our triangle here. So we can make our triangle here, we can join this, and that becomes our opposite end of the right triangle, and that is the adjacent side of our right triangle, correct? And we can count the units and then measure. So we have 1 here and 1, 2, 3 units here, correct? So this side, let's call this point as Q. So we have PQ, which is the distance from the point to the curve, is equals to 1 square plus 3 square square root. So 1 square plus 3 square square root, which is equals to square root of 1 plus 9, which is square root of 10. So that is the exact answer. And if I have to write it in decimal numbers, then I need the help of my calculator and then figure out what it is. Square root of 10 is 3.1622. So we say it is 3.1622. And if I have to round it to 2 decimal places, so then I will get 3.16. Okay, so this is approximate to 2 decimal places. Okay, and this one is my exact answer. So depending on what is asked in the question, you need to answer this. Okay, so the graphical is interesting. You have to visualize and look for a point, and it seemed to me that that point Q could be a good point, and then we drew it and found that it was really a nice point to find the shortest distance of the point from the curve. Okay, I hope you appreciate the method. Thank you.